Wait, really? I'm pretty sure, yeah. The final one here is comprehensive, right? Yes.
First thing I want to do is just make some generalized announcements as of today. I worked to come up with almost the rest of the semester. So when you go on Blackboard, you'll not only see this week's information posted, but now you will see next week's and Thanksgiving week posted. But now I combined them since we only meet one day of that week. And we're actually not meeting that day because you decided to do things on Zoom. I mean, you decided not to do things on Zoom. Keep my classes straight. So, but that means that you're responsible for the material. So I listed what you should be going over that day. So anyhow, you should see pretty much all of the rest of your information. Two other things. Number one, I will be passing back your exams. And today is the W deadline. My schedule is tight, but if you have a question about where you stand, I will not tell you what to do. But if you have a question about where you stand, I will answer that question. Because I do have columns in the grade book that I've got hidden right now because they don't make sense to most people until the end, where I can predict what your grade would be if you did not drop a test, and I can predict what your grade would be if you dropped the test. given all the other drops. So I can kind of give you a little bit of an idea about where you stand. Like I said, though, my schedule is kind of crazy today, so it's going to be, you better get that email in early if you are even on that cusp of questioning. I ask that if you're not questioning, please don't email me. But if you are questioning where you stand, to know whether to drop or not, then email me. Yes. I do all the drops at the end. Because I won't know what your worst test grade is. I won't know what your worst homeworks are and stuff until the very end. I mean, I've got it kind of in there, but that's why it doesn't make sense as of this moment. The only other thing I was going to mention is that as far as for next week, the only thing I haven't done is the answer keys for the homeworks, and I'm going to try to get them done this weekend so that you have the homeworks and for the following week. So the optional homework. Any questions?
Is our last one our final? Are you gonna make that the 13th for last day?
Okay, so your fourth exam is December the 4th. And your final, according to the university, is December 11th. I don't know the time without looking it up on the syllabus, but I know it's December 11th. Other questions? Yes.
If we do extra credit things that are due on the 15th, are we supposed to like bring the paper to your office, or are we supposed to email you?
So that is Friday. It depends upon what it is. For those bringing in cans, you got to bring it to my office, and you'll need to bring it in before probably 1:30, 2 o'clock. If it is the paper, you can just email it to me.
I remember you saying something about not everyone having to take the final exams.
So basically, if you like your grade with your first 4 exams counting, you don't have to take the final. I'm dropping a test grade, whether it's one of the first 4 or whether it's the final. Other questions? If not, I'm going to pass back everything I have for you. A couple of folks, the reason I said everything I have for you is because a couple of folks have some things in that have never gone back to them. Julie Berumen. Isabella Blair. Ashlyn Boudreau. I will get this correct. I try to say it too fast. Isabella Brown. Nick Wee. John Burgess. Brendan Cagle. Bailey. No. Contreras. Ty Crow. Zoe Davis. Hannah Gatson. Cynthia Gonzalez Omegar. Megan Hall. Marissa Hartless. Ali Hernandez. Hannah Hicks. Taylor Hill. Jamia Hodges. Jamia Holt. Brittany Wynn. Maya January. Kia Johnson. Joey Larkin. Zoe Lowry. Mallory Marshall.
Thank you.
Addie Mickle. Michaela Morrison. Adia Muhammad. Danielle Newton. Winnie Wynn. Hayden Ocker. Lily Peters. Gracie Pickens. McKinley Pickens. Kelby Fly. Hayden Pounds. Ross Price. Nika Roman. Janie Reed. Erica Samlet. Ashton Tran. Michaela Watson. Avery White. Li Jing. Adam York. If I missed anybody, come get it. Folks, the way it worked out is every single one of the questions on the front page were 2 points apiece. So that was 60 points of the exam. I did that on purpose because for the most part, people did better on the back page than on the front page. Question number 2 was worth 48 points. So each block was worth 4 points apiece. Question number 3 was worth 20 points each. 20 points. So each one was worth 4 points. And then question number 4, part A was worth 12 points. Sig figs didn't matter. And question number B was worth 10 points. I should say sig figs and units. I will be posting the answer key. Need to keep it out so I don't forget, so that you can check your answers. If I made a mistake, let me know. Now, I was very careful on the endings though, or tried to be very careful on the endings. Because while I would give a little bit on spelling errors could not occur with the "ide," the "ite," and the "ate." Otherwise, you would change the identity. So again, I will post the answer key. Probably tomorrow. Any questions? Yes.
Like, want to take the final, just to see if we could do better and help our grade, and then we decide we don't like that.
I always take whichever one's best. I'm not going to hurt your grade. Like I said, I drop your lowest, whatever the lowest is, that will be the grade I drop. Same number of points, but it is cumulative. So it's everything. Which means there's a lot less naming on it. Other questions? Folks, I mean, there was somebody that did make an A on this test raw score. But I did curve the test by 7 points. So on Blackboard, you will see your score 7 points higher than it is on the test. Hopefully, what this illustrates going into this 4th exam for most people is you want to tackle it early. Don't wait until the day or two before the exam to study. I think, though I can't quantify it, but just from experience, that is one of the most common mistakes that's made on the naming exam is people still want to wait and study like they normally do. And that one, you definitely can't do that. So it takes starting out studying. I would start out working the problems. I would try to get the problems worked. The homework problems for this week are already posted. It's next week's that I have to do. So you can already start trying to tackle some of those problems and see if you can't score well on this last exam, which will be mostly mathematics. Okay, we're gonna get started into today's information. We're gonna try to do I'm gonna do two things. Number one, I'm gonna start with just a problem, like what we've been doing the last couple of days in class. And then we're gonna move on to balancing chemical reactions. So, I gave this example at the end of class. What mass of silicon chloride contains 2.96 times 10 to the 24 chlorine atoms? I used this example to show you how the flow chart would work, but let's do the math and actually do this calculation. So I have been given 2.96 times 10 to the 24 chlorine atoms. I have been asked to solve for the mass of silicon chloride. The first thing I notice is that they are different substances. So I'm going to use a mole to mole. The mole to mole comes from the chemical formula. According to the chemical formula, 1 mole of silicon chloride contains 4 moles of chlorine. The next thing, so that was the first thing I noticed, is different substances. The second thing I noticed is the word atoms. Atoms means that I am going to need Avogadro's number, which is 6.022 times 10 to the 23rd of anything. In this case, chlorine atoms equals 1 mole of that thing. So 1 mole of chlorine. The next thing I notice is that I'm working with grams of silicon chloride, tetrachloride. Anytime I see grams, it means I need the molar mass. I have 1 silicon and I have 4 chlorines. Silicon has a mass of 28.09. Chlorine has a mass of 35.45. So the silicon contributes 28.09 to the overall mass, and the chlorines contribute 141.8 for a total mass of 169.89. Oh goodness, you can't read that, can you? The mass is 169.89 grams of silicon tetrachloride is equal to 1 mole of silicon tetrachloride. Now, I'm ready to solve. 2.96 times 10 to the 24 chlorine atoms. My first conversion factor needs atoms in it, so I'm using Avogadro's number. 6.022 times 10 to the 23rd chlorine atoms is going to be equal to 1 mole of chlorine. Next, I'm going to use the mole-to-mole ratio to convert from chlorine into silicon tetrachloride. There are 4 moles of chlorine for every 1 mole of silicon tetrachloride. And finally, I can convert that into grams by multiplying by the molar mass of silicon tetrachloride. I chose what went in the denominator so that the unit and the substance would cancel. So for my first conversion factor, I put chlorine atoms in the denominator so that they would cancel out. For my second conversion factor, I put moles of chlorine in the denominator so it would cancel out. And for my third conversion factor, I put moles of silicon tetrachloride in the denominator so that they would it would cancel out. Now that I have this ready to calculate, you key this in and you're going to get 208.7655 grams of silicon tetrachloride. Now we need to worry about significant digits. There are 3 significant digits in our original value. In Avogadro's number, the denominator has 4 significant digits, while the numerator, which is the mole, is an infinite number of significant digits. In the mole-to-mole ratio, mole-to-mole ratios will always have an infinite number of significant digits for both the numerator and the denominator. And then for our molar mass, the mass portion had 5 significant digits, while the mole portion had an infinite number. So the measurement with the fewest had 3. So you would report this answer as 209 grams of silicon tetrachloride. Questions? Okay. So after our first exam, we learned the chemist's alphabet. We learned the periodic table. With after our second exam, we started combining our alphabet to make words, which happen to be the formulas for chemical compounds. Just like in an English class where you combine words to make sentences, a chemist combines words to make a sentence, but our sentence is a balanced chemical equation. Now, balanced chemical equations are always written in the same format. On the left-hand side are the reactants. On the right-hand side of an arrow are the products. Reactants are substances that start the reaction. Products are the results of the reaction. And I use RXN as a short notation
Let's see.
for writing out the word reaction. Now, reactions must follow the law of conservation of mass. As a reminder, that means that mass cannot be created, nor can it be destroyed. What this means is, since each element has its own mass, the quantity of an element on the reactant side must be equal to the quantity of that element on the product side. Now, to accomplish this, coefficients are added to precede the formula of the reactants and the products. A major note: and that is, do not alter the formula of a compound when balancing reactions. Okay. So let's look at how to balance a chemical equation. We're going to start with a fairly straightforward chemical reaction. There are balancing chemical equations. I can give you some steps, but for the most part, it is a matter of trial and error. The steps that I can give you. Before it's trial and error. The first step is to make a list of elements present in the reaction. Now note, there is a note here. And that is, if a polyatomic ion exists in the reactants, and that polyatomic ion exists in the products, then list the polyatomic ion as a unit when writing the elements. Step 2 is to identify how many of each element is present in the reactants. Three, identify how many of each element is present in the products. Four, make the number on the reactant side match the number on the product side. by altering the coefficients. Now, some hints. Include start with elements that appear in one reactant and one product first. Save elements that are in compounds by themselves. For last. The last step is to simplify, because coefficients must be in the smallest whole number ratio possible. Okay, we're going to look at a couple of quick examples, but we'll do more on Friday, and we'll do more difficult ones also on Friday. Not hard, it's just they're going to be more difficult than what I'm about to do. So let's look at, we'll go with this one. Fe plus O2 goes to make Fe2O3. Just to identify, the left-hand side are the reactants. The right-hand side are the products. And those are separated by an arrow. When we talk about the coefficient, we're going to talk about a number that we will place in front of the formula. Those will be our coefficients. Okay, so I see that we have Fe and I see that we have O. On the reactant side, there is one Fe according to the formula. And there are two O's according to the formula. On the product side, there are two Fe's and there are three oxygens according to the formula. Now, to make the oxygens equal, I need to multiply the left-hand side by 3. 3 times 2 is equal to 6. Whatever you multiply by becomes the coefficient. To make the two sides equal, we need to multiply the right-hand side by 2 to get 6. Whatever you multiply by becomes the coefficient. That 2 in front of Fe2O3 means that we have 2 Fe2O3 molecules. So we wound up with 6 oxygens, but we also wound up with 4 irons. Now to balance the iron. On the left-hand side, I have 1. On the right-hand side, I have 4. To make the two sides equal, I need to multiply the left-hand side by 4. Whatever you multiply by becomes the coefficient. Basically, folks, again, balancing a chemical equation means that the quantity of each element is equal. The quantity of each element is equal. Notice I did not alter the formula, I only altered the coefficient. Let's look at another example. H2 plus Cl2 goes to make HCl. You cannot alter the formula. All you can do is alter the coefficients that precede the formula. On the left-hand side, I notice that I have hydrogen and I have chlorine. On the left, I have 2 hydrogens according to the formula, and on the left, I have 2 chlorines according to the formula. On the right-hand side, I have 1 hydrogen and I have 1 chlorine according to the formula. The two sides are not the same. To make the two sides equal for the hydrogen, I am going to need to multiply by 2. And that will give me my 2 hydrogens. Whatever you multiply by becomes the coefficient. Now that 2 means I have 2 HCl molecules. So I wound up with 2 hydrogens, but I also wound up with 2 chlorines. And so I have equivalent quantities on the two sides of the equation. Let's look at HGO goes to make Hg plus O2. Again, the only thing you're going to be allowed to alter is the coefficients of the equation. You cannot alter the formula. I have mercury and I have oxygen. On the left-hand side, I have 1 mercury and I have 1 oxygen. On the right-hand side, I have 1 mercury and I have 2 oxygens. This equation is not balanced because the 2 sides are not equal. To make the 2 sides equal, for the oxygen, I am going to need to multiply the reactant side by 2. Whatever you multiply by becomes the coefficient. But that literally means I have 2 HGO molecules. So I wound up with 2 oxygens, but I also wound up with 2 hydrogens. I mean, 2 mercuries. Now the mercury's not equal. On the reactant side, I have 2 mercuries. On the product side, I have 1. To make the 2 sides equal, I need to multiply the product side by 2. Whatever you multiply by becomes the coefficient. So the equation is 2 mercury, 2 oxides, goes to make 2 mercuries plus 1 oxygen. Questions? We will do a lot more of these on Friday. That will be the only thing we're doing on Friday is just balancing chemical equations. They will get harder.